Now look at this question. It looks like a huge one, and it is obviously for 5 marks. We need to prove this thing, and we have been given a polynomial x square minus px plus q, and we need to prove alpha square by beta square plus beta square by alpha square should be equal to p raised to 4 upon q square minus 4p square upon q plus 2. Let's find out. Okay. So obviously I'll take the left hand side first, and I will definitely try to reach to the right hand side. But before that, when you always have a polynomial, I know you need to find two things, that is alpha plus beta, which is minus b by a. So minus of minus p upon a is 1. So minus of minus p will be plus p. Okay, and immediately I'll find product of the zeros, that is alpha beta, which is c by a. So c is q and a is 1, so it goes q. Fine. Now let us talk about the left hand side. So first let me write LHS, and then what is there in the left hand side? So we have alpha square by beta square plus beta square upon alpha square. Now one thing is for sure, you have to cross multiply this, correct beta? So alpha square into alpha square, it will be alpha raised to 4. Beta square into beta square, this will be taken beta raised to 4, and whole divide by, the denominators are multiplied, so I have alpha square beta square. Correct? Alpha square into beta square. Done. This much is all okay. Now to the numerator. You know how to arrange alpha raised to 4 plus beta raised to 4. I can do it as, I can take this as alpha square plus beta square the whole square minus 2 alpha square beta square. Correct? And now the whole thing divided by beta alpha square beta square. So I can simply write this as alpha beta the whole square. Fine. Now which is equal to this, also I can write further, simplify. So I can simplify this as alpha plus beta the whole square minus 2 alpha beta, the square sign of this, and minus, I can take this as 2 alpha beta the whole square, and whole divide by, listen, it's alpha beta the whole square. Alpha beta is q, so I'll be having denominator as what? Q square. Fine children, I hope you got this mathematics till now. Now alpha plus beta, that's p. So p the whole square, I'll be getting p square minus 2 alpha beta. Alpha beta is q, so I'll be getting 2q and the whole square of that minus alpha beta q, so I'll be getting 2q square and whole divided by, I have q square again. Fine children. Now here I can use a minus b the whole square, so it will give me a square plus b square minus 2ab. So a square means I'll be getting p raised to 4 plus b square means I'll be getting 4 p square, no, it will be 4 q square, okay, minus 2ab. So I'll be getting minus 2 p square. So into 2 also we have, so we will be adding 4 if I am not wrong. So I'll be getting 4 p square q. This is a square plus b square minus 2ab. Okay, and I also have minus 2 q square along with that, and the whole divided by I have q square with me. Fine, children. Now, can we solve something here? Yes, we can solve something, because 4q square minus 2q square, I'll be having plus 2. So I'll write this as p raised to 4 plus 4q minus 2q. So I'll be having plus 2q square. This is minus 4 p square q, and whole divide by q square beta. I hope I am getting it to the right answer. Okay. Now, what I'll do, last step, I just need to separate the denominator one by one. Okay. So let's get the last step done. So we have p raised to 4 upon q square plus sign. We have 2 q square divided by q square. Then we have a negative sign. 4, I got p square q divided by the denominator q square. Fine, children. Now, so the first fraction cannot be solved, so I'll keep it as it is. I'll write this first. Here one of the q gets cancelled. So what is the remainder? I'll be having 4p square divided by q. Here q square gets cancelled, and what is the remainder? 2. And clearly see, this is nothing but the right hand side, what we wanted to prove. Okay, I hope you got this maths. This question is surely going to come for 5 marks in the paper, your board exams. Clear? So if you have any query related to any of the steps, you can message directly, or you can get back to me on my Instagram as well. Okay, so done. Thank you.